Cool. Yeah, so I'm Topher. You heard the whole intro. I'm basically here to talk about a bunch of different practices that we have in place at Pivotal that have really, for me, been a learning process, being at the company for like 5 years and going through this whole process of understanding all of the technologies that we're building and all of like our goal. Because we really have like this really lofty, ambitious goal of transforming how the world builds software. And really our focus is on adoption of cloud technology and really architecting applications for the cloud first. And we're really using this adoption of cloud technology to transform the whole organization towards these goals. So when we work with clients, we're really helping these companies transform the way that they think about building software, not just where they're deploying it and how they're using it, but also sort of the ideas behind how they do those things and the organizational process behind it. But for me, I'm on the cloud R&D team at Pivotal, and we're really building the products and open source solutions that help these companies transform the way that they build software by deploying to the cloud. So we're really working on a lot of like open source solutions and enabling that transformation through building products for our customers. And it really feels like, as an R&D team internally at Pivotal, we're transforming how we're transforming how we build and deploy software, and then we're sort of helping the world figure out how to do that and work the way that we work after we've ironed out all the problems and figured out all this stuff and sort of made these tools and platforms and open source solutions that help them move all their business to the cloud. And to give a sense of this, I'm going to focus on sort of the two main command line tools that I use every day as an engineer at Pivotal. And really give my personal experiences. This isn't my views are all mine, and this isn't really a Pivotal supported thing. My views don't necessarily represent the views of Pivotal. This is really just my experience as a pivot working on all of these cloud products. So CF Push is focused along application lifecycle for modern cloud platforms. Take an app, put it in the cloud. And Bosch Deploy handles sort of the deployment of all of these microservices architectures that are, allowing us to say CF Push, take my app right in the cloud, and stand this thing up on VMs and do all of the cloud lifecycle management and configuration management to actually get all that stuff up and running. So we have a lot of agile teams that are working on things like Concourse, which is our CI and CD tool that we're building in-house, and Cloud Foundry, which is a platform as a service application lifecycle management. And we also have teams that are deploying the underlying, it's really not showing up very well, but there's some underlying VMs that are actually needed to run all this stuff. They need to deploy all these microservices to get these things running. And so they use Bosch to manage all of this cloud infrastructure that needs to be set up. It's configuration management similar to Puppet and Chef, but it also has more lifecycle management built into it as well. And then these teams are standing this infrastructure up so that they can build a bunch of apps and continuously integrate and deliver them using Concourse and deploy those things to Cloud Foundry. So we have sort of this big, long view of all of the tools that, as an engineer on the CFR&D team, I've sort of had to learn and understand this whole life cycle of I'm doing DevOps and I'm managing my own deployments. I'm managing the infrastructure that these apps are being deployed to, and I'm also continuously delivering them to this cloud platform. And how do I wrap my head around all of this stuff? And we've really distilled this down to this whole idea of being cloud native. And this is really purpose building your applications with the cloud in mind, and really leveraging all of the great stuff that you get from using a cloud platform, using a continuous delivery tool, and using something that can really do the DevOps side of things and make that life easier for you, like Bosch. And this really allows you greater agility and the ability to really start delivering quickly. And it also gives you the ability to move across different clouds and different infrastructures as you're going. We'll get into that more later. And really, when you're building the apps, you need to think about similar ideas as 12-factor apps. This is a big manifesto that was put out by the people at Heroku. Basically talks about how you build your applications so that they can run on a modern cloud platform. And I'm not going to cover all 12 factors here. There was a great talk from last year at SATURN by, I think it was Matt Momont from GE, and it was a great talk. And I'm just going to go through sort of the high-level mission statement of like what 12-factor apps is really like, what that manifesto is trying to get at in terms of how you should build your applications. So you really want to use like declarative formats for setup and automation. So CF will handle this by allowing apps to define a manifest of what services they need to integrate with, how much memory they roughly need, and how many instances of that they want. And it takes all of this stuff and all of this configuration, and because CF is really convention over configuration, it takes this small configuration and goes and runs that in the cloud for you. And so if you focus on having applications and being able to deploy applications that are very configurable, you can harness all of the great stuff of the platform. You don't need to worry about, if I move this thing from this development environment to this test environment, will I be able to run it in this setup on CF? Cloud Foundry just takes this configuration and can run your application. It does a little bit of process in terms of figuring out what your application is. So there's a build pack process which knows, hey, like this looks like a Ruby app, so I'm going to deploy it as a Ruby app. This looks like a Java app because there's a POM file in there. This looks like a Node app because there's Node modules sitting in here and there's a bunch of JavaScript files. And really this configuration is sort of built into the platform and it knows how to read all of this stuff. And these declarative formats really define the interface with the underlying system. And one of the other tenets of the 12-factor app, just from the first top above the fold description of what it is having a clean contract with the underlying system. So for Cloud Foundry, your application is, as far as it's concerned, just a process running, listening on a port. And because it can distill your application down to, it's just a process running in a container, listening on a port, it can take that process and have it be compiled down for running on its cells that are doing all of this container orchestration for you. And it can treat your application as a very simple unit of computing and can scale it out to multiple different containers. And you don't really have to worry about that. Because there's a clean contract, because there's a well-defined structure of CF of how it wants you to structure your application. It wants you to pull this port from some configuration that it's providing you. It's just giving you an environment variable saying, this is the port you should listen on for us to be able to network and route traffic to your application cells. So this standard really helps the platform take your application, run it in the cloud, and do it effectively. So then, it's going to be suitable for deployment on modern cloud platforms. CF really is a modern cloud platform. It will handle all of the details of keeping that application running in the cloud. You know, it's going to do log aggregation, it's going to do scaling, it's going to do networking, it's going to do all of the routing to your application. And you don't really need to worry about all of the details of how it does that as an application developer, as long as you follow the contract that CF is setting out for you. So then once you follow all these rules, your app is truly going to be capturing all of the ilities that modern applications really need to follow to run in the cloud. And you get to leverage all of these ilities that the cloud just gives you for free, the cloud platform gives you for free. So then once you've designed your app cloud first and you've designed it to purposefully be built for the cloud, you can take that app and run it on any instance of CF. You don't really need to worry about where it is, whether it's in a dev or test or prod or user acceptance testing. You don't really need to worry about what's going on underneath the covers. As long as it's a CF, you can push to it, you're good to go. So by following all these principles, you sort of get to this Cloud Foundry Zen of being able to say CF push in your command line, in your application directory where all your source code is and some configuration for how it should run in CF. And then you just say, hey, Cloud Foundry, here's my source code. Run it in the cloud for me. I do not care how. Now, this is a good quote from our VP of R&D at Pivotal for Cloud R&D. And what was interesting about the keynote from yesterday is about like software as details. And like what I found was really interesting is like often maybe we can sort of treat the underlying system as just details and know that the details will get figured out by this larger platform, and you don't really need to worry about what's going on in the underlying system. There's some machinery in there that runs it in the cloud for you, but as an app developer, I just want to get it in the cloud. I don't need to worry about all of this containerization stuff and like how to scale it and do all this stuff. I don't want to go out and start spinning up VMs myself and standing up my software on it and then putting in all the monitoring and log aggregation and figuring it out. I just want a cloud platform to just like do all of this stuff. So to like illustrate this, like all I need to do is take some source code and spit it at a Cloud Foundry. And as a software developer, just making an app, I can say CF push, and then some stuff, some machinery goes on in there, and I have an application. It's figured out that this is a piece of Go source code, and it's made some containers inside of CF that are running Go plus my source code, and has compiled it all down to just be a process listening on a port, and has figured out all of the different details that it needs to understand to actually do that. It'll also keep it running. It'll monitor that that process is still up and listening on that port, and if one of those containers starts to misbehave and that process suddenly stops, it will bring a new one up and very quickly be able to handle that graceful failover between the containers. And I don't really need to worry about this stuff. I happen to know about it because I'm on the team that's building CF, but as an app developer, if I'm just given a CF environment, I don't really need to worry about what's going on in the inside of it. And there's a lot of other examples of ways that this can be done. I'm not saying CF is the only way that this can be done. You can really replace this with any other modern cloud platform that's going to do all of this for you. And really the same things ring true. If you have a good, solid platform, your application developers don't need to care about what's going on inside of there. It could be Kubernetes, it could be making Docker containers, it could be any other sort of containerization standards, but it doesn't matter. And like, it will just scale it up for me. And I realized a funny thing about this slide as I was like just sort of high level describing how things worked is that like, this is horizontally scaling this application out, but in my slides, I put it vertical. I don't know why I did that, but what's cool is I don't even need to care about how it's scaling that stuff. I can just give it some source code and not worry about it. But Cloud Foundry itself is a bunch of systems working together. The microservices architecture running on VMs. And it's just, containerization is just one layer of it. Developing apps and pushing them to it is really just happening on the containerization level, and it's all just being compiled by a bunch of different components to get these things onto containers. But there's a whole lot of stuff that goes on inside of CF, and someone needs to deploy and manage that. Generally with us, we're deploying and managing our own CF environments to be able to develop applications for Cloud Foundry. So we need to figure out who keeps the lights on for the app developers. Who keeps it so that I can just send some source code to this CF and I don't need to worry about it. And so really like, when something is just details for one person, it's someone else's problem to worry about the details of that. Things just sort of get abstracted away, and as you go deeper, someone else is going to need to care about making that thing work. And so for us, our tool of choice for that is Bosch. And as I said earlier, it's sort of like Ansible, Puppet, or Chef, all of those like configuration management type tools, but it has this sort of second added layer of like lifecycle management for the cloud. So it's going to manage all of the VMs and all of, standing up all of those services and setting up instances and deploying it to it. And it really deals with talking to the infrastructure that your VMs are running on. So Bosch deploying is sort of similar to CF pushing, in that you can say, here are my servers, go make them a Cloud Foundry. I do not care how. So similar abstractions have been built out in Bosch, where it has the understanding of, okay, you want to make a bunch of VMs, you want to run a bunch of services on them, you want them to be roughly this scale, you want them to be networked together in this way. I'll go ahead and do that. Just give me some configuration that describes that in a high level, and I'll go do all the dirty work inside this infrastructure, pipe all these things together and stand up all these VMs for you. And as was mentioned this morning, microservices architectures are complex, and one of the concerns around that complexity is how you deploy these things. You don't want to go and start manually standing up all of these VMs and sticking things on them and networking them all together. You really want a tool that can deploy these large distributed microservices architectures to the cloud and just take your Bosch deployment and say, hey, Bosch, make me a Cloud Foundry. And a lot of these 12-factor tenets or guidelines for how they built the 12 factors ring similar for infrastructure automation. Infrastructure as code is a declarative format for how you are going to automate your infrastructure. You want to stand up a bunch of VMs, so why not have some configuration for what that might look like? And so for Bosch, there's a whole bunch of YAML files that you'll wind up dealing with. I've made a joke that we're sort of like enterprise YAML architects at Pivotal. I even got, I don't know how I managed to do this, but I got our director to actually get us shirts made with that on it. That was one of my I think one of my top accomplishments at Pivotal. It's definitely up there, top 3 is getting a shirt with that slogan on it. And it was actually used at CF Summit to make a point in someone's presentation, in the open source Cloud Foundry keynotes, and I was like, I've made it. I've really made it. Anyways, that was a sidebar. For deploying your software using Bosch, you really set up these deployment YAMLs. And this is an abstract view of what all of this YAML sort of captures. So you're on the left there, you're sort of capturing what services you want to deploy. These are just some random names of services that make up a Cloud Foundry deployment. And you're also specifying, how many of those do you want? What sort of availability do you need for these things? Or what sort of scale do you need these things to run at? And then you're also defining some rough idea of what VM sizes you want these things to run as. And what's important is that you're not giving it a specific VM type. You're not saying, I want this to run on this specific type of Amazon EC2 instance, and I'm going to really specify it in here and hard-code it in here. You're giving it a high-level configuration, a declarative format to say, okay, this is sort of roughly the image high level of what I want my deployment to look like. There's also some networking in there, and it sort of gives you this high-level overview. It's almost like an architecture diagram, but it's several lines of YAML. And that definitely gets a lot larger as you're building up these YAML files and building things up. And there's a lot of tooling around sort of composing these things together and having sets of services defined as separate YAML files and bringing everything together and enterprise YAML architecture. It's great. You also want a clean contract with the infrastructure as a service. So this is one of the great things about Bosch is that because you're defining your deployments as these sort of amorphous ideas of what should be deployed, you have this really declarative configuration. You need to have a really clear contract with, okay, what's the IaaS going to do with this stuff? How do I know what it's going to do? And how do I abstract that away from my deployment? This is really something we've been thinking a lot about in terms of the architecture of Bosch itself. So for Bosch, you can take your deployment YAML, with some services and some VM sizes. And you just have a CLI locally on your computer, and you can stand up this Bosch director and a CPI. And I actually, again, I screwed up in my slides, in that these are actually two separate components now. Previously, the director and the CPI were really coupled together. You would set up this director and this built-in CPI into it. But now you can actually say, hey, I want to stand up a director on AWS, and then I want to install the AWS CPI. So it's really two separate things working together. So the cloud provider interface, which is CPI, is really responsible for going in and mucking around with the infrastructure. It's the thing that knows how to speak AWS. It's sort of like we take the director and we're setting up this little agent that is just a really small idea of, okay, I can pull in some deployments and then I can maybe go out and find some other interface to go and talk to this infrastructure. And then we say, hey, here's your interface. You now are managing AWS services. You're managing EC2 instances. And then it's like, oh, hey, I know AWS. So then it can reach into AWS and actually make your deployment happen. It can set up all these VMs and figure out what's going on. And what happens inside of the director layer is that it contains the distinct configurations of how these vague ideas of different sizes of VMs should actually be carried out inside of the infrastructure. So, I have a micro and a medium for maybe like some smaller web services that I'm running. And then, I have some high memory and some high CPU instances in case I need to do anything high memory and high CPU. Maybe I have some specific services that need that. And it just maps these things in your deployment over to a distinct microservices architecture that's being deployed. And what's cool about it is it's actually doing some lifecycle management as well. So it knows how to take your services, and the CPI will create a VM for you. It will create the VM at the size that you specified in your cloud configuration, your distinct idea of what a small VM should be. And it'll install a base OS on that, some Linux operating system. And it will also keep that operating system up to date. So it installs this base image, and as long as you have the most up-to-date ones on your director, it will go and install this new base image. So if there's a CVE for Linux, it will just go and create new VMs for you really quickly and just take this deployment, make a new VM for you with a new updated OS. You don't need to worry about it. And then it installs your software on it. Whatever services, whatever processes need to be running inside of this VM, it will monitor them, and then it will scale it up to however many instances you need, and it will network them together within your larger architecture. And then this really makes suitable for deployment across multiple clouds. So because we've abstracted out this layer of the Bosch CLI, which is the user-facing thing, you're developing these configurations for how things should be deployed. And then there's the CPI layer that actually goes in and does all of the hard mucking around in the IaaS to create these VMs and set all this stuff up. Then you don't really need to worry about the details of multiple clouds until you're actually getting to the process of setting everything up and saying Bosch deploy. And then you need to figure out, okay, like what VMs am I sizing this as? But really, it's just a bunch of configuration, and the CPI layer does all of this for you. So it really handles all of the uptime of these VMs, and it's dealing with all of this for you because it knows how to deal with that specific infrastructure. So you just know that it has this very clean contract, and you just need to give it this very rough idea of your deployment setup beforehand. So we actually did this at Pivotal. We moved a lot of our deployments from Amazon over to GCP. And what's cool about this is we actually worked really closely with Google to develop the CPI for GCP as we were testing out this whole process. So sort of as we were developing this and as Google was actually building the CPI for Bosch, we got to really interact with them and see how this process would be for our clients and for customers who were using CF and for open source users of CF. And really, in a few weeks, we were able to migrate a whole lot of deployments over and diversify to sort of really treat these infrastructures as undifferentiated heavy lifting. So this is what Amazon often talks about in their keynotes. They'll talk about how stop spending money on this undifferentiated heavy lifting. We can just give you these magical VMs and you can just set them up. And Bosch really lets us treat these things as this sort of opaque layer of, I just want a VM that's some rough size, and I'll figure out the distinct size once I actually set up a director on that infrastructure. But until I'm actually at the process of doing it, my deployment exists as just this rough idea. So I can take a director, set it up in GCP, give it a GCP CPI, and then it can just go about the process of standing that up and setting it up with the exact distinct representations of all these VMs that I want to set up. And it goes and installs the software for me. And I don't need to worry about keeping the uptime of these VMs. Bosch has this health monitor built into it, and it just watches these things. And the CPI lets it know how to speak different ISs. This also works, interestingly, for changing network details. So I can change from one availability zone to another. I can sort of migrate across a cloud into different availability zones, or I can deploy the same deployment across different availability zones and then have redundancy. And this really lets me minimize the divergence between different deployments. So I can take this deployment, maybe scale it a little bit, and change some of the high-level details of what this architecture looks like, and I can have a dev deployment or a test deployment. So just like taking this and modifying it a little bit, I can have one deployment and maybe automate this, because these are very high-level overviews of what my deployment should consist of. I can tweak some of these details, and I can automate this whole process. And I can say, okay, like I want to take this and deploy to test. And maybe the test instance of it, there's only one of that blue one because it's big, and we don't want to spend a lot on our test environment, so we'll have one of the big blue thing. And maybe two of those because we don't really need it for a development setup. Lower instance sizes, lower counts of how many things we're scaling up. And that really lets us deploy the same rough idea of an architecture, but maybe with some different scaling setups for dev or test. Animations are all screwed up. So what's cool about this is then we can deploy these things to multiple different clouds. And we actually have a team at Pivotal that's using Concourse, which is our CI and CD tool, to make a bunch of manifests for deployments, and then take those things and deploy them to all of the different clouds. And then they use this for testing all of the Pivotal products. So we actually have a whole pipeline that goes out and reaches out into all the different infrastructures and tries out deploying to all of these different IaaSes. And because the CPI can be just swapped out for all of these different infrastructures, we don't need to worry about the underlying details of it, because we know we're just going to get a VM, we're just going to run a process on it. We don't need to worry about it. And what's really weird is that Concourse itself can be Bosch deployed. It's just a bunch of running services. So actually on the Concourse team, anytime there's a new Bosch release of Concourse, a new set of the actual source code that goes into the releases that are the processes that are running on these VMs, we can go and redeploy the Concourse that is actually packaging everything up to deploy it. So it's sort of like we're swapping out the wings on the airplane while we're still flying it. So that's kind of the end of it for me. I really encourage everyone to sort of look into all these different tools. They're all open source. Like I said, you don't have to buy anything. I'm not here to sell anything. And yeah, just look into how cloud platforms can really change the way that you build apps and deploy the cloud.
All right. Thank you, Topher. Any questions?
Thank you, Topher. Question. How many of the 12 factors are really necessary to run an app in PCF?
Oh. I'm trying to think of what the bare minimum, the bare minimum for an app. I guess there's sort of different layers of it, right? The configuration side of things, it is a lot better if you are reading configuration from sort of the CF standard, which is pulling things from environment variables. You very much need to listen on the port that CF tells you to listen to, so you need to be pulling at least that environment variable as configuration, but the rest of your application doesn't necessarily need to do that. And then, checking things into Git is not necessary, but source control is part of it's one of the 12 factors. I guess really the main things are reading configuration. The only factor you really need is to be reading that port to be able to run your app. Depending on the application, right? If it's a simple Ruby application that's just a web server, all you need to do is tell Ruby, hey, listen on this port that CF is telling you to listen on, And like that's maybe the only factor that's needed. I'd have to think about that.
Other questions? One more. I have a question. When we started with Cloud Foundry back in 2013, we started on AWS, and I'm not aware. And I know the Azure. I saw the demo with Azure. I wasn't even sure that we have. So, what are the maturity of the two other infrastructure as a service? I know you started with AWS.
Yeah. So what's going on here? Yeah, definitely the maturity is growing up, and because we've separated the CPI layer from the director layer, we're actually allowing the vendors, like the IaaS vendors themselves, to contribute to these cloud provider interfaces. So that really ramps up our ability to deploy to these different infrastructures, and it's getting more and more mature as days go by. It's been really interesting to see the progress of the Google Cloud Platform CPI, because this has really been like only, I would say, less than 2 years in the making. Like, I don't really know when the engagement started, and I can't speak to that, but it's been mind-blowing how fast they've been able to turn things around and how fast it's been able to sort of ramp up to the same feature set as other cloud providers. Yeah.
All right. Well, again, a round of applause for Topher. Thank you so very much.
I'll be around afterwards, so if anyone has any other questions.